What we need to look at now is a complete thermodynamic cycle. We start from point A to B, B to C, C to D, D to A again. So we have to consider what is happening here. Is there work done by this cycle? Is more work done by the gas or on the gas? Well, you remember, in going from B to C, P times delta V, that work done is equal to P delta V, is going to be a large value because it's the area under the BC line. On the other hand, going from D to A, there's going to be a negative value because it's going to the left. In other words, the volume is being reduced, the work done is negative. So the difference is basically the area inside the thermodynamic cycle. But we also know that, for example, with isochoric increase in pressure, there will be some thermal energy that will make that happen. We also know that if we keep the pressure the same and the volume is getting bigger, it could be because there was an import of thermal energy here. And also, by the same argument, thermal energy is coming out here, and thermal energy is coming out here. Well, you know that the gas is doing more work on the surroundings than the surroundings is doing on the gas. So basically you're getting some energy for nothing, but you're not getting the energy from nothing because you have to put thermal energy, more thermal energy into the system than you're getting out. So the gain in work that you get is basically because of the extra thermal energy that you're putting in. So in the expansion, you go from B to C, the work done is positive, so that's the area here. The work done going back again, which the work done on the gas, which is going to be negative, is going to be a smaller area. Let's take that one step further. You know, during the expansion from B to C, the area under the graph is the work done by the gas on the surroundings. So it's delta W or WBC. Likewise, going from D to A, there's a contraction. This is work done on the gas. Which is greater? Well, the area under BC is greater than the area under DA, so therefore, expansion does more work than the contraction. Where does this energy come from? It comes from the fact that you put more thermal energy in going from A to B and from B to C than you do from C to D and D to A again. So this energy comes from heating. So basically, the heat that you put into the system is able to do work. And this is called a heat engine. We get heat to do work. On the other hand, if we imagine this thermodynamic cycle but in reverse, so it's in that anti-clockwise direction, we know the expansion from A to B does a certain amount of work. The contraction from C to D does also work on the gas. Which one is greater? Well, we know that the work done on the gas is greater than the work done by the gas. So in other words, this system is able to get energy because you're doing work to it. What does the system do with this extra energy? Well, we know that more energy in is given out in CDA than is given in ABC. So we have basically a heat pump. We're using this system, we're doing work to this system to basically get heat to go from one place to another. So by doing work, we can get heat to go from, for example, a cold place to a hotter place. That doesn't usually happen. So the work done can transfer heat. So it basically takes heat and pumps it uphill. In other words, from a cold place to a hot place. This is not what usually happens. Normally, heat goes from hot to cold, not cold to hot. You can make it go from cold to hot, but you must do work to make that happen.